Alright, so we are going to review hydroxyl compounds consolidation exercise 1. This is quite a difficult one. So I'm going to go through step by step in the problem solving process so that you guys will have a clearer picture how we can go about getting the answers. The question seems deceptively simple because of the relatively simple molecular formula of C10H12O2. So probably the first thing we want to do, right, is to determine the degree of unsaturation. So you can easily determine it by performing a straightforward calculation, 2n plus 2. So the maximum number of hydrogen a 10 carbons compound can have will be 22. So that will be 22 minus 12 divided by 2. So that will be 5. Yeah. As per what we have given you in your lecture notes, if you have a C to H ratio that is close to 1:1, you can sort of safely assume that you can have a phenol ring. And then of course over here with 5 degree of unsaturation, 4 of it can be attributed to a phenol ring. Okay, note that this is phenol ring, means a benzene ring with a substituents, could be 1, 2, 3 or 4, 5 or even 6 substituents. So that in general requires a phenol ring. We avoid calling a benzene ring because benzene normally refers to C6H6. So with degree of unsaturation, we can relatively accurately pinpoint 4 of it is due to a phenol ring because we know that a phenol ring contains 4 degree of unsaturation. 1 of it is unknown, which of course can be a question mark. We might not know what it is at this stage, but of course when you read on, right, then it will be clearer what the final degree of unsaturation is. Yeah, so this is the first point you kind of like need to mention. So remember that the way to showcase your understanding of structural elucidation questions, right, when you present your answers, right, is to tabulate your answers. So we have an info here, and then we have a deductions. Okay, so whatever that's mentioned here will point to deduction number 1. Yeah, so we're going to then what about the information? We can just say that the formula is C10H12O2. Okay, so that will be very clear cut how the information is related to the deduction, or what deduction can you make from the given information. Okay, so I'm just going to color code whatever I'm writing so that it's easier for you to follow. I'm not going to write down the deduction in full because that will spend a lot of time, unnecessary time, and in the process there will be a lot of viewing time, so that's not necessary. Okay, so I'm just going to go straight into the deduction process, but along the way I'm just going to pinpoint to you, okay, so this is what you need to write under your deduction. Okay, so the second point is 1 mole of A, right, reacts with excess sodium metal to give 1 mole of hydrogen gas. So this is the second point that needs to be mentioned here. So this is the second point that you could actually go on and write down under the info and deduction. So what does that entail? So in that sense, we need to dig into our memory a little bit. Are we able to write down a balanced equation involving sodium and protonic hydrogens? I think that is a very important learning point you need to gather from working on structural elucidation question. You need to be very, very strong in your concepts. Yeah, so you need to know most if not all of your organic chemistry concepts at the tip of your fingertips when you are working on the problems. Okay, so I'm just going to write down an equation here. So that will be R OH, okay, plus sodium. Okay, then I'm going to produce the alkoxides, or for the purpose of carboxylic acid, that will be carboxylate, but I am just going to put it as a generic alcohols. Okay, then Na plus plus half H2. So for every 1 mole of alcohols, or for that matter protonic hydrogens, okay, I'm going to get half moles of H2. Yeah, so that actually implies that if I'm going to get 1 mole of hydrogen gas instead of half moles of hydrogen gas, that means that I'll have 2 equivalent of protonic hydrogens. Yeah, so I can write down in the deduction here. Okay, so I'm just going to write down in point form 2 equivalents of protonic hydrogens, HYDROGN. Okay, yep. Then the third point, so I'm going to change my color. So the third point is when warm with aqueous alkaline iodine in a water bath, A gives a yellow PPT. So that will be the third point here. Okay, now so I'm going to move down here, third point. Now we have not gotten the deduction for our final degree of unsaturation, so this remains as a question mark. Yeah, then normally for third point, right, we know that this is a positive iodoform test. Positive iodoform test. So normally, right, for most of the students, they will tend to write down all possible answers. Okay, so what do I mean by writing down all possible answers? So they will say that, from here, right, I can deduce that it contains, maybe you can say A contains, you can say this, okay, carbon, double bond O, CH3, and the methyl alcohol as the structure features. H as structure features. Yeah, but in our case here, right, there is no room for either or. You can be quite sure that is one of the two. Why is that the case? Okay, the reason being, right, we have two oxygen here. Okay, I need two protonic hydrogens. So each of the oxygen must be bonded to one protonic hydrogens. Yeah, so if one of the oxygen is being taken as a ketone, then it is kind of like not possible for the other hydrogens or the other OH, right, to give you 1 mole of hydrogen gas, because you only end up with half mole of hydrogen gas. So in this case, you can be, I don't want to put it like 100% sure, but in our case here, you can be really 99% sure that it's likely to be the methyl alcohol. So you don't need to write either or. But of course, if you are not convinced, and at that point in time, you're still not very sure, right, you can write either or. Yeah, but if you think further, it is not possible for you to have protonic hydrogens, two equivalent of protonic hydrogens in only one O's. Yeah, so in that case, I need the other OH to be around. Okay, so because of that, right, I can sort of make the conclusion that I will only have this particular structure as the structure feature. So OH, CH3, this as the key structural features. Okay, then if you are going to move on, right, especially to the fourth point, this is the fourth point. A decolorizes aqueous bromine in the dark to give this and this as the major product. This is probably the most difficult point you will encounter, at least in this particular question. I do believe that is the case, because a lot of the students will sort of make mistakes here. So I'm just going to expand out 4. So there are a few things you can gather from here. So number 1, right, if my side chain, okay, contains this as the structure features, so that leaves the final degree of unsaturation to be likely just due to a CC double bond. Could that be the case? Yeah, likely to be, right, because you know that it can't be a ketone, and you only have C, H, and O. So of course, a CC double bond would be the most likely options. So if I have a CC double bond, right, then over here I expect electrophilic addition to occur. Electrophilic addition to occur, right? Because I'm looking at aqueous bromine. Yeah. So if electrophilic addition were to occur, right, so I'm going to get something like this, to something like this, to a OH and a Br. So I'm going to get a bromohydrin. Am I right to say that? Yeah, yeah. So based on this fact alone, okay. So we're going to work it one by one. Yeah, we're not going to put everything together, because putting everything together can be really confusing. So we're going to work one by one. Okay. So because it's an addition, right? So I can simply just add Br and OH to the molecular formula given to me. Okay. So what I'm going to do now is I'm going to take C10 H12O2, right? I'm going to add BrOH. So I'm going to add a H, O, and Br. Okay, and then I'm going to get C10 H13 O3 Br. Okay, so this is what I'm going to get. I'm going to compare with my formula. My formula is C10 H12 O3 Br. You notice that it's a bit different. Yeah, in the sense that I'm missing 1 Br by 1 extra H. Yeah, correct. I mean that's the idea I get. I mean, you can get from here. Then another question arises lah. Where is the other protonic hydrogens? Yeah, because you know that from the limited information we are given, you know that one of the protonic hydrogens, right, must be from the methyl alcohol, right? So this one must be from here. Yeah. Then what about the other protonic hydrogens? Yeah. So yeah, you need to put the clue side by side. Like I need to have an extra protonic hydrogens, and at the same time, it is able to sort of allow the decolorization of aqueous bromine. And you might be thinking, from electrophilic addition, it decolorizes really well. What other kind of reaction involving protonic hydrogens or OH that allows the decolorization of aqueous bromine in the dark some more? Yeah. Then knowing that this is the chapter on hydroxy, right? Perhaps what that comes to your mind, right, is likely to be phenol. Yeah. So we can test it out. If let's say it's a phenol, right, for OH, does it constitute to the two equivalent of protonic hydrogens? I think that will make perfect sense really, because one of it is the methyl alcohol, and then the other one is likely to be phenol. Then does it ring a bell that under aqueous bromine, phenol undergoes electrophilic substitution? Yes, so it does ring a bell, right? Electrophilic substitution. Correct. So so the generic electrophilic substitution of phenol, right, is that I'm going to get 2,4,6 tribromophenol. Yeah, so that's the generic one. But based on what we have understood earlier on, right, on this, using this formula, and of course over here, right, we are just missing one BR. So because we are missing one BR, right, then we can be quite sure that two of the position must be blocked. Yeah, so in order for me to block the two position, then I'm going to block maybe here with a group R1 and then maybe R2 over here, right? Then when I block two position, then it is possible for the remaining electrophile to come into this position, which is the 6th position. So does that make sense to you? Right? You can think about it. Okay, so I'm just going to erase this. So this is very dynamic because I'm writing on the screen. Okay, so you know that I'm going to block one of the position. So because I'm going to block one position, right, I'm going to replace 1H for 1Br. So I'm going to minus 1H because it's a substitution reaction. Okay, so I'm going to get C10H12O3Br, and I'm going to add 1Br. Okay, then we'll see if we'll eventually end up with the molecular formula C10H12O3Br2. Yeah, indeed we get C10H12O3Br2. So based on this, right, I think point number 4, right, there are a lot of conclusions that can be made. Number 1 is electrophilic addition, electrophilic substitution, and then we can also conclude that it's a tri-substituted, or rather A is tri-substituted, or you can say A is tri-substituted benzene. I think that might be more straightforward. And then of course now the task is to find out what is R1 and R2, and that will not be too difficult because based on what we know, okay, so number 1 is that it's a phenol. Okay, it's a phenol over here, and I need one of it to be a methyl alcohol. Am I right to say that? Yeah, so I need to put that in. I can't extend the chain because minimally, right, I need to have 2 carbon for a CC double bond. So then my 4th position will be a CC double bond. Yeah, so I can't have a CC double bond with only 1 carbon. Yeah, so therefore the remaining 2 substituent, or the remaining 2 substituents for the substituted phenol, right, must contain 2 carbons. Yeah, so this drawing, this particular structure will be one of the answers for A. Okay, so we can do a quick count. 6 carbon here, 7, 8, 9, 10. So that's C10. H12. Do I get H12 over here? Oh, sorry. The formula for A, yes, is H12O2. Okay, so I'm just going to count. So 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so O2, 2 oxygen. So that's perfect. Okay, and then what about the product? So okay, so this is A, right? So this is A. This is one of the A. And then what about B? Okay, so B, I'm going to draw the most the product that is obtained in the largest U. So this remains, and then For electrophilic addition, the Br is likely going to come here, and then with a positive charge carbocation, because it's stabilized by resonance, or you can say that the electron density of the phenyl ring, right, will be able to delocalize and help to stabilize the carbocation. So the water will attack here, so the bromohydrogen will be formed here. Yeah. So this will be one of the products. You're not required to draw the iodoform test product, because they did not say that when one with aqueous alkaline iodine, A give a yellow PPT as together with the carboxylate salts. Yeah, they did not ask you to draw, so you don't have to draw it out. Okay, so I'm going to get this. So that's one possible product for B. So I'm just going to call it B1, and that's A1. Okay, then you might be wondering then, what about the rest of the answers? Okay, so the rest of the answers is just swapping the groups around, if you want to. So basically, I can swap these two. Okay, I can swap these two, or I can swap these two. Yeah. So sorry, I can't swap the fat. I can't swap the OH, because if I swap the OH, then there will be other issues involved. So if I swap this, if I swap these two, then I can swap the alkene with the OH. Yeah. So that will give me a total of 3 possible structures. Okay. Yeah. The most common mistake that students make earlier on in the tutorial, right, when I went around, is they propose something like this, which is definitely a possible answer. However, this will give you a product that contains 3 bromine, not 2 bromine. Yeah, the reason is if this will undergo electrophilic addition and electrophilic sub, I'm going to end up with the Br here, the OH here, the Br here, and the Br here. So you will notice that it will not be able to fit the molecular formula of B. Yeah. So because of that, then this is not a candidate, not contestants for the 3 structures of A and B. Okay. Yeah. So so we're only looking out for one answers. I mean one combination of the answers, that is a tri-substituted benzene, that is A, or a di-substituted phenol, you can no matter how you call it. Yeah. So I presented to you one of the A1 and one of the B1, and I'll leave it to you to go and draw out the remaining 2 possible structures. Okay, so that will be the end of the review for consolidation exercise 1 for hydroxyl compounds.